Observational techniques and meticulous analysis couldn't have possibly been done in the 1700s or even in the 1800s. This type of knowledge requires modern tools, which is why the reality is just coming to light now. Recent research has brought about a re-evaluation of these beliefs. New findings have led scientists to somewhat reduce their estimate of Andromeda's mass, while simultaneously increasing the mass attributed to our Milky Way. As a result, the current understanding is that the masses of these two cosmic giants are much closer than previously thought. So if you were to be on Andromeda and looked at Earth, you'd see just as massive of a galaxy. This puts into perspective how colossal the Milky Way itself is too. The Andromeda galaxy's physical dimensions, though, are what astronomers totally agree on. It's known to stretch farther than our own Milky Way, with an impressive diameter of about 212,000 light-years. Andromeda surpasses the Milky Way's estimated diameter of roughly 100,000 to 175,000 light-years, making it a truly significant cosmic entity, taking over a large region in space. This revised perspective also highlights the complexities and challenges of accurately measuring the mass of galaxies. In the heart of the Andromeda galaxy, the supermassive black hole exerts an immensely powerful gravitational pull on surrounding stars. As these stars orbit around the black hole, they follow elliptical paths similar to planets orbiting the Sun in our solar system. At a certain point in their elliptical orbits, stars come closest to the black hole, known as the perihelion. At the perihelion, the gravitational forces are at their strongest, causing the stars to move at their highest speeds. This is when the stars bunch up and become more concentrated in space around the black hole. As they bunch up, the stars release energy in the form of radiation, including visible light and other types of electromagnetic radiation. The increased concentration of stars and the release of radiation create the brighter point of concentration that astronomers observe in the galactic core of Andromeda's active galactic nucleus. An active galactic nucleus, popularly known as an AGN, is a highly energetic region at the center of a galaxy. It is characterized by intense emissions across various wavelengths, from radio waves to X-rays. AGNs are powered by the presence of a supermassive black hole at the heart of the galaxy. These supermassive black holes are incredibly dense regions in space where an enormous amount of mass is concentrated within a very small volume. When astronomers observe active galactic nuclei using advanced telescopes like the Hubble Space Telescope, they notice a very interesting phenomenon. One of the most fascinating features of the Andromeda galaxy is its AGN. It appears to have 2 points of concentration, meaning there are 2 distinct regions where light and other forms of radiation are emanating more intensely than in the surrounding areas. The brighter concentration is the second point of focus, which is just slightly off the true galactic center. Within this area lies the supermassive black hole. The mass of this black hole has been estimated to be between 1.1 to 2.3 multiplied by 10 to the power of 8 solar masses, which means it weighs approximately 110 to 230 million times as much as our Sun. Supermassive black holes are believed to be common in the centers of galaxies, including our own Milky Way. As a result, they play a crucial role in the evolution and dynamics of galaxies. When matter such as gas and stars gets too close to a supermassive black hole, it forms an accretion disk around it. This disk of swirling material heats up and emits intense radiation across various wavelengths, which is why the AGN is highly luminous. When astronomers observe the active galactic nucleus of the Andromeda galaxy, they notice a brighter point of concentration near the central supermassive black hole. This feature is a result of the unique gravitational interactions between the black hole and the stars in its vicinity. The Andromeda galaxy also has another super interesting feature: an abundance of globular clusters. These globular clusters are tight groups of stars that orbit around the center of the galaxy, kind of like satellites revolving around a planet. Andromeda is estimated to harbor around 460 of these dense and ancient clusters, each containing hundreds of thousands to millions of stars that formed around the same time. The incredible number of globular clusters in Andromeda offers valuable insights into its cosmic history and interactions with smaller galaxies over the course of billions of years. It suggests that Andromeda has been an active devourer of these smaller galactic companions, a process known as galactic cannibalism. As smaller galaxies come within Andromeda's gravitational reach, immense forces strip them of their stars and other components. The stars from these cannibalized galaxies become part of Andromeda's stellar population, adding to the rich diversity of stars present in the galaxy. This characteristic of accumulating globular clusters and stars from smaller galaxies is considered typical for spiral galaxies like Andromeda. Spiral galaxies, characterized by their disc-like shape with distinctive spiral arms, provide an ideal environment for interactions and mergers with smaller companions. In addition to its other intriguing characteristics, recent observations and analysis have sparked speculation among astronomers that the Andromeda galaxy might be undergoing a fascinating transformation. It appears to be transitioning from being a typical spiral galaxy to a relatively rare type known as a ring galaxy. Ring galaxies are intriguing and relatively rare celestial objects characterized by their circular or elliptical ring-like structures. The rings consist of bright, young, and blue stars, while the central region contains relatively little luminous matter. These unique features make ring galaxies stand out among the vast array of galactic structures. There are three main types of observed optical ring phenomena: nuclear rings, inner rings, and outer rings. Nuclear rings are located near the center of a galaxy, while inner and outer rings are a bit further out. Additionally, there are two primary types of ring galaxies, O-type and P-type. O-type ring galaxies have centrally located nuclei, and their rings are smooth and regular in shape. On the other hand, P-type ring galaxies have off-center nuclei, and their rings tend to be more irregular. Ring galaxies are considered rare cosmic gems, with only approximately 1 in 10,000 galaxies classified as them. Astronomers have proposed two main mechanisms for the formation of ring galaxies. First, they can form through the collision of two or more galaxies. Second, a smaller galaxy passing through the center of a larger galaxy can also trigger the formation of a ring-like structure. Examples of ring galaxies thought to be formed through galactic collisions include the Cartwheel Galaxy, Galaxy AM 2026-424, and ARP 147. But it's not just a simple process. There are lots of intricacies at play. What's happening right now is even more interesting. Scientists say that the Milky Way galaxy and the Andromeda galaxy are on a collision course and will eventually merge to form a new supergalaxy. This colossal event has already garnered nicknames like Milkomeda or Milkdromeda, since it's known worldwide. However, while these nicknames may be playful, the consequences of this merger for humanity could be devastating. The merging process can trigger bursts of star formation in regions where gas clouds collide and compress, creating new stellar nurseries. These nurseries become the birthplaces of young massive stars fit for the new galaxy. As the galaxies merge, the night sky becomes a cosmic light show with stunning displays of star clusters, shock waves, and bright bursts of radiation. New constellations and stellar arrangements emerge, transforming the entire sky into something brand new. But amidst this grand spectacle, there are deeper effects. If life were to emerge in the new galaxy, it would likely undergo adaptation to the specific conditions of its environment. Different physical and chemical properties of the new galactic region could give rise to a unique form of life distinct from what we know on Earth. But humans of today won't be able to survive in this new galaxy. Our galaxy, for example, is the Milky Way galaxy, and the nearest galaxy to us is the Andromeda galaxy. We think there are about 100 billion galaxies in the visible universe. The Andromeda galaxy has been instrumental in reshaping our understanding of the universe and our place within it. For instance, while our galaxy is the Milky Way, the nearest one to us is Andromeda. We estimate there are about 100 billion galaxies in the visible universe. This discovery provided compelling evidence that the cosmos and the concept of creation don't revolve around Earth. It shattered the notion that the Milky Way was the sole galaxy in existence, suggesting we're just a tiny part of the vast universe. Our knowledge about Andromeda has grown over the last century, primarily through observations made on Earth. However, with advanced tools like the James Webb Space Telescope, JWST, now at our disposal, our perspective has drastically changed. Surprisingly, recent data from the JWST has challenged our previous notion about the Andromeda galaxy, presenting another cosmic puzzle to solve. The JWST has received unusual signals from our neighboring galaxy, leaving the scientific community astonished. Join us as we explore how the JWST received an alarming signal from the Andromeda Galaxy. The perception of the Milky Way has evolved significantly throughout human history, shaped by our developing understanding of the cosmos. In the past, when our technological capabilities were limited, the Milky Way appeared as a hazy band of light across the night sky, inspiring various interpretations and mythologies. It was often seen as a mystical and central element in the cosmological beliefs of different cultures. In the 1920s, Edwin Hubble, an American astronomer, made a transformative discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. Through observations and analysis, Hubble showed that distant nebulae beyond the Milky Way were actually separate galaxies, each containing billions of stars. One of the closest of these galaxies was the Andromeda Galaxy, also known as M31. Andromeda has a rich history of observations dating back centuries. One of the earliest known records of this celestial object can be traced back to the 10th century, when the Persian astronomer Abdul al-Rahman al-Sufi described it as a small cloud in star charts from that period. The significance of these observations lies in the fact that al-Sufi was able to identify this distant cosmic entity without the help of telescopic instruments, relying solely on his keen eyesight and observations. Later, in 1612, a more detailed description of the Andromeda Galaxy, based on telescopic observations, was provided by Simon Marius. His work laid the foundation for future astronomers to study this massive cosmic structure. In 1764, the renowned French astronomer Charles Messier catalogued the Andromeda Galaxy as M31 in his well-known Messier catalogue, mistakenly attributing its discovery to Simon Marius, unaware of al-Sufi's earlier work. But that doesn't mean that he didn't have a major hand in putting Andromeda on the map. For almost 100 years after this, astronomers worldwide were trying to understand more and more about this mysterious galaxy, each adding to the last one's findings. Before that, Galileo Galilei, an Italian astronomer, actually revolutionized our understanding of the Milky Way in the early 17th century. Using his newly developed telescope, he made groundbreaking observations that challenged the prevailing Aristotelian cosmology. He discovered that the Milky Way was not just a diffused light band but a massive collection of individual stars, planets, and other celestial objects. Through his observations, he demonstrated that the Milky Way was not at the center of the universe as previously believed, but instead a vast expanse of stars scattered throughout space. In 1750, English astronomer Thomas Wright proposed a new hypothesis in his work, an original theory or new hypothesis of the universe. According to Wright's speculation, the Milky Way was not a random distribution of stars in space, but a completely flat layer of stars. He also suggested that a portion of this vast structure was our own solar system. While Wright's hypothesis was a step forward in understanding the structure of the Milky Way, it was still limited by the observational technology available at that time. They all still believed that the Milky Way was all there was to it, and considering the limitations, that's not surprising. A significant leap in understanding the nature of the Andromeda Galaxy occurred in 1864, when the English astronomer William Huggins made a groundbreaking observation. He studied the spectrum of Andromeda and noticed that it was different from that of a typical gaseous nebula. This paved the way for the world to really get to know Andromeda for what it really is. While it's a lot, the Andromeda Galaxy has a mass estimated to be between 1 and 2 trillion times that of our Sun. It's a colossal cosmic structure that just happens to live relatively close to us in the vastness of space. In all the research conducted until now, scientists believe that Andromeda is about 10 billion years old, making it quite ancient in cosmic terms. Its age hints at a long and intricate history of formation and evolution. One of the intriguing aspects of Andromeda's origin is the hypothesis that it came into being through the merging of several smaller protogalaxies. This suggests that over billions of years, smaller galactic entities gradually came together under the force of gravity to form the majestic Andromeda Galaxy we see today. Such galactic mergers are common occurrences in the cosmos, shaping the growth and structure of galaxies. For a long time, astronomers thought Andromeda was significantly more massive than our own Milky Way galaxy. From an objective point of view, a mistake like this could easily be made because we're in our own galaxy, and seeing Andromeda from Earth does make things look so large that you'd easily think that there's no way anything could even come close to its size. But that's not the case. Galaxies are immense systems, and their mass is intricately linked to the distribution and movements of stars, gas, dust, and dark matter within them. Pinpointing these values precisely is a demanding task that requires sophisticated technology.